Namaste. My name is Partha Majumdar. I'm a student of Masters in Indian Knowledge System from Bhishma School of Indian Knowledge System. My PRN is 23110779. This is a submission for paper PO Science 2, paper code MI06. In this video, I will discuss ancient India's scientific culture. Ancient India stands as one of the great cradles of human civilization, where profound philosophical insights and advanced scientific achievements emerged hand in hand. India's scientific culture is rooted in spiritual traditions and manifests in various disciplines like mathematics, astronomy, medicine, and metallurgy. The intellectual landscape of ancient India reflects a deep seated commitment to inquiry, observation, experimentation, and codification, forming the basis of scientific tradition that influence the Indian subcontinent and the wider world. Ancient India's scientific tradition stands apart in the global history narrative due to its unique metaphysical and empirical inquiry integration. Scientific exploration was not a separate or isolated pursuit, but deeply interwoven into with philosophical, spiritual, and ethical frameworks, creating a holistic approach to understanding the universe. Central to this tradition was the ancient Indian education system, which fostered scientific learning in a manner distinct from contemporary cultures. One of the most defining aspects of Indian scientific tradition is its philosophical groundings. While primarily spiritual, the ancient texts, notably the Vedas and Upanishads, laid the foundation for astronomy, mathematics, and medicine. The texts exhibit deep interest in existence, causality, and the cosmos. Concepts like Ratha, cosmic order, in the Vedas form the basis of later explorations in astronomy and cosmology. Similarly, the Upanishads' contemplation of the self and the universe influenced future metaphysical inquiries that overlapped with scientific reasoning. Among the earliest examples of scientific thought is the work of Kanada, the founder of Vaisheshika school of philosophy. His atomic theory posited that the universe is composed of individual particles called paramanu or atoms, an idea remarkably similar to the atomic theories developed centuries later in the West. Kanada's work demonstrates the profound philosophical underpinning of Indian scientific inquiry, as his atomic theory was not merely speculative but tied to the understanding of cause and effect, motion, and the transformation of matter. Such contributions were the product of brilliant individuals and reflected the unique education system prevalent in ancient India. The Gurukul system, where students lived with their teachers in calm and disciplined environments of the forest, was pivotal to nurturing young minds, intellectual and spiritual development. The system strongly emphasized holistic learning, combining philosophical, scientific, and practical knowledge with ethical, spiritual guidance. The focus was on imparting information and shaping individuals capable of deep inquiry and reflection. The Gurukul system fostered an environment of close interaction between the teacher, the guru, and the student, the Sishya. The relationship was built on trust, discipline, and the pursuit of knowledge. In such a system, students were taught to observe nature, engage in critical thought, and question the principles of reality, all within the peaceful surroundings of nature. This learning method helps students to develop a sharp intellectual understanding and a sense of responsibility towards society. As they were often encouraged to meditate and contemplate on teachings of the Vedas, the students were trained to approach both spiritual and material realms with balanced perspective. In this way, the Gurukul system significantly contributed to the India's scientific and philosophical advancement. The cultural openness of ancient India allowed scientific knowledge to flourish across different regions and traditions. Scholars from other parts of India and even beyond its borders interacted dynamically to exchange ideas. The Buddhist and Jain traditions also contributed significantly to the cross pollination of knowledge, with monasteries serving as learning centers where astronomy, mathematics, and medicine were pursued alongside religious studies. One of the most celebrated contributions of ancient India to the world of science is mathematics, the foundation of which is now called modern mathematics, can be traced back to Indian scholars such as Aryabhatta, Brahmagupta, and Bhaskara too. Aryabhatta, an iconic figure in Indian mathematics, made groundbreaking contributions to algebra, arithmetics, and trigonometry. His work, Aryabhatiya, includes approximation of pi and introductions to methods for solving quadratic equations. Brahmagupta is credited with developing the concept of zero as a number, an innovation that revolutionized mathematics and enabled complex calculations. His work also elaborates on negative numbers and rule of arithmetics. Bhaskara too is known for his comprehensive treatise Leelavati, delved into algebra and calculus centuries before similar concept emerged in Europe. Bhaskara's theorem of cyclic quadrilaterals and his work of solving Pell's equation highlights the advanced nature of Indian mathematics thoughts. Indian mathematicians also made significant advancements in geometry. The Shulba Sutras, composed around 800 to 200 BCE, contain precise geometrical knowledge applied in Vedic rituals, including concepts akin to Pythagorean theorem centuries before Pythagoras. Closely linked to mathematics, astronomy in ancient India evolved in a sophisticated scientific discipline. Vedic literature contains numerous references to celestial bodies, and the Indian astronomers made some earliest efforts to map the skies and calculate time. The work of Aryabhatta, Varahamihira, and Brahmagupta are prominent examples of accomplishments in this field. Aryabhatta's assertion that the earth is spherical and rotates on its axis, leading to the observation of day and night, was a remarkable insight. Additionally, Indian astronomers made significant strides in understanding lunar and solar eclipses, debunking the mythological explanation prevalent in other parts of the world. Aryabhatta's calculation of solar year as well as the motion of planets reflects the high level of precision in Indian astronomy. Indian scientific heritage is also deeply rooted in medical traditions of Ayurveda, one of the world's oldest systems of medicine. Compiled in texts like the Charak Samhita and Sushruta Samhita, Ayurveda presents a comprehensive understanding of health, disease, and anatomy, and surgery and pharmacology. Charaka, the author of Charaka Samhita, laid down the systematic approach to diagnosis and diseases and treatments, incorporating the three doshas, Vata, Pitta, Kapha, as fundamental physiological elements. His emphasis on diet, ethics, and mental state as factors contributing to health reflects a holistic approach to medicine. Sushruta, the father of surgery, compiled the Sushruta Samhita, which includes detailed description of surgical procedures such as cataract surgery, rhinoplasty, and various orthopedic operations. His text is also one of the earliest known to describe plastic surgery. The Indian understanding of medicine was deeply empirical, as evidenced by its vast pharmacopoeia. Using herbs, minerals, and metals for healing laid the groundwork for modern pharmacology and chemistry. Ancient India also excelled in metallurgy, producing some of the finest examples of metalwork ever seen. The Iron Pillar of Delhi, a 1600-year-old structure that resists corrosion, is a testament to India's advanced metallurgical knowledge. Indian blacksmiths were highly skilled, producing Damascus steel, which became famous for its strength and durability in sword making. The method for crafting wood steel, a precursor to modern high carbon steel, was closely guarded secret and was exported to the Middle East and Europe. Furthermore, Indian engineers exhibited remarkable skill building complex irrigation systems, stepwells, and fortresses. Indian hydraulic engineering was advanced, supporting agriculture and urbanization by managing water resources in cities like Dholavira and Mohenjo-daro. The scientific culture of India was not confined to subcontinent. With the rails and trade routes, Indian knowledge system traveled to Persia, the Middle East, and Mediterranean world. Indian numerals, for example, was adopted by Arab mathematicians, and through them, they reached Europe as Arabic numerals we use today. The interdisciplinary nature of Indian science, with its confluence of spirituality, philosophy, and empirical research, ensured that it is a living tradition constantly evolving and adapting. The Indian intellectual tradition was marked by a dynamic exchange of ideas, where empirical observations were often framed within philosophical discussions about the nature of universe and existence. Namaste.